and subtract vectors.
As Sharon just said, we're going to learn about how to add and subtract vectors because that's really important in operating on vectors and their applications. If we're adding two vectors v and w, we can do that either graphically or analytically. We'll talk about the graphical solution first. If we're adding two vectors, say a vector v and a vector w, let's say v is 100 magnitude at 20 degrees, and w is 70 magnitude at 120 degrees, and we wanted to find the resultant vector of adding v plus w, what we're going to do first is create a copy of w by translating w on over to where the start of w is at the end of v. And by start and end, I mean the starting point is the origin of the vector, the ending point is where the arrow is on the vector. A vector, again, is a directed line segment. So, what we do, a copy of w that starts at the end of v, but has the same magnitude and direction as w. Those two vectors, v and the copy of w, form two legs of a triangle, the third leg of which is the resultant vector. This purple vector here is the result of adding v to w. And remember, since two vectors are equivalent if they have the same magnitude and direction, creating that copy of w is still w. They're equivalent vectors. So therefore, this is a graphical solution for adding two vectors. And if we wanted to find the actual dimensions, the magnitude and direction of the resultant vector, graphically, we'd have to measure it. If we did everything to scale, the length of the vector r would be the magnitude, and the angle that it formed with the x-axis in the mathematical system we use is the direction of the resultant. Now, if we're going to do vector subtraction, v minus w, what we have to do first is create a negative w. A w traveling in the opposite direction with the same magnitude by reversing its direction. So we create that copy of w that's called negative w. So instead of going from the origin to the direction of w, it goes in the opposite direction. And then we translate that negative image of w, that negative w, to the end of vector v and start. Its start is at the end of vector v, and then its end is going to be a very important point. So now we have v plus negative w, or in other words, v minus w. And the third leg of the triangle that's formed by v and negative w is the resultant vector of v minus w. And again, if we want to find the magnitude and direction of that resultant vector, we're going to measure the length and use a protractor or some other device to measure the angle that it forms. So that's how you do graphical vector subtraction and addition. If we want to do it analytically, and this works for addition or subtraction, first we have to find the magnitudes of the horizontal and vertical components of both vectors v and w. Both the vectors we're adding or subtracting. And you'll recall that I is a unit vector, a vector with magnitude 1 in the direction of 0 degrees, or in our system, the positive x-axis. J is a vertical unit vector with a magnitude of 1 and a direction of positive 90 degrees, straight up in the vertical direction. So we got to find those horizontal and vertical components of the two vectors, and then we're going to add kind of like terms. The horizontal components we're going to add together, and the vertical components we're going to add together to find what the new vector, the resultant vector, is. So if we've got vectors v and w, we use trigonometry to analytically determine the horizontal and vertical components of both vector v and vector w. And for example, for vector v, the x component, or the horizontal component of vector v, would be the magnitude of v times the cosine of the angle it forms, with an I there, indicating that it is a horizontal vector. Similarly, the horizontal component of vector w would be the magnitude of w times the cosine of the angle it forms, I'm calling that beta, times I. And then on to the y components, the vertical components. V sub y, the y component of the vector v, is equal to the magnitude of v times the sine of alpha the angle it forms, times j. And you'll recall that's because it's opposite over hypotenuse, where the vertical part is the opposite. In a similar way, w sub y is the magnitude of w times the sine of angle beta times the vertical unit vector j. And when we combine those horizontal components together, the v sub x and the w sub x, that becomes the horizontal component of the resultant vector. In other words, the resultant vector, the horizontal component, is equal to v sub x plus w sub x. Similarly, for the vertical component, the vertical component of the resultant is equal to v sub y plus w sub y. And I put the plus or minus there because if you are subtracting the vectors, the same process works. We're just going to subtract the components instead of adding them. Another thing to keep in mind is sometimes sine and cosine are negative depending on the angles. Just put that in and it should work itself out. To find the magnitude of the resultant vector, you're going to use our magnitude formula, which again is like the distance formula. It is the square root of the horizontal component's magnitude squared plus the vertical component's magnitude squared. And that makes sense because there's a right triangle formed by the vertical component and the horizontal component of this resultant vector as well. To find the direction, again, we use the inverse tangent because we know the opposite side and the adjacent side of the angle that's formed, and we want to find the angle. So that angle, which I'm calling theta, would be the inverse tangent of the vertical component divided by the horizontal component, opposite over adjacent. Let's go ahead and do an example of this. Let's use the previous example, which we used for a graphical solution, where the vector v is 100 magnitude at a direction of 20 degrees. The vector w is 70 magnitude at a direction of 120 degrees. And we want to find out what v plus w is. Now, we already kind of determined it graphically by moving w over to the end of v. But we want to find precisely what the magnitude and direction are, so we want to use an analytic solution here. So let's break down vector v. The horizontal component of v sub x, is equal to v times the cosine of alpha. In this case, it's 100 times the cosine of 20 degrees. That's approximately 94, and don't forget to put in the I because it's a unit vector in the horizontal direction. Similarly, the vertical component of v, vy, is equal to v times the sine of alpha. So it's 100 times the sine of 20 degrees, which is approximately 34.2 in the j direction. Let's break down vector w into its components. W sub x is equal to w times the cosine of alpha, which is 70 times the cosine of 120, which, by the way, is a negative number because the horizontal component is moving off to the left. It's negative 35i. W sub y is equal to w times the sine of alpha, so it's 70 times the sine of 120 degrees, a positive 60.6j. And that makes sense because its vertical component is going up, but its horizontal component is going left, therefore it's negative. Let's go ahead and combine those horizontal and vertical components to get the horizontal and vertical components of the resultant force. So the resultant component in the horizontal direction is equal to v sub x plus wx. That's 94i minus 35i, and that's equal to 59 times I. In the vertical direction, the component is vy plus wy. That's equal to 34.2j plus 60.6j, which is equal to 94.6 times j. To find the magnitude of the resultant force, we take the square root of the magnitudes of the vertical and horizontal components squared, so it's the square root of r of x squared plus ry squared, Pythagorean theorem. Square root of 59 squared plus 94.6 squared, which is approximately equal to 111.5. We can also figure out the direction of the resultant vector. It's equal to the inverse tangent of the y component over the x component. Inverse tangent of 94.6 over 59, which is approximately 52.8. So in the end, our resultant vector is a magnitude of 111.5 units at 52.8 degrees. So we looked at how to add and subtract vectors, both from a graphical and an analytic standpoint, by taking their components and breaking them down and adding the components or subtracting them together.